See non-luminous objects. When light falls on a non-luminous object, part of it bounces back from the object. We can see the object when this light reaches our eyes. This bouncing back of light by objects is called reflection of light. When light falls on an object, a part of it is bounced off from its surface. When this bounced light falls on your eyes, we can see the object. All objects around us bounce off a part of the light falling on them. The bouncing of light from a surface is known as reflection of light. When a ray of light hits a surface and the light ray which bounces back is called reflected ray. Terms used in reflection of light. Incident ray. The ray of light from the source that strikes a given surface is called the incident ray. See here, my dear children. The ray of light from the source that strikes a given surface is called the incident ray. The point at which the incident ray strikes the surface is called the point of incidence. See here, my dear children, the point where the incident ray strikes the surface, that point is called point of incidence. Next here, reflector ray. The ray of light that bounces back. The ray of light that gets reflected back or bounces back at the point of incidence is known as reflected ray. Next here, normal ray. The perpendicular to the surface at the point of incidence is called the normal ray. Next, angle of incidence. The angle between the incident ray and normal ray is called angle of incidence. See here, my dear children. Incident ray, the angle between incident ray and normal ray is called angle of incidence. Next, my dear children, angle of reflection. The angle between the reflector ray and the normal ray is known as angle of reflection. See here, the angle between the reflector ray and normal ray is called angle of reflection. There are two laws of reflection. The first law states that the incident ray, the reflector ray, and the normal at the point of incidence all lie in the same plane. Now, what does this long sentence mean? Let's take a closer look. The first law talks about the incident ray, the reflector ray, and the normal. All these three things lie on the same plane. Now, what does plane mean? Plane is a flat surface, just like a sheet of paper or a table surface. So, which plane are they talking about here? This is a common confusion. Is it the mirror? That's right. It's not the mirror. In fact, the first law does not even talk about the mirror. It's this flat surface that is perpendicular to the mirror, and as you can see, the incident ray, the reflector ray, and the normal are all lie on this flat surface, which is our plane here. The second law of reflection, thankfully, is much easier. It states that the angle of incidence is equal to the angle of reflection. As you can see in the picture here, the angle of incidence is 40 degrees, and so is the angle of reflection. Now, if I change the angle of incidence by moving this torch, as you can see, the angle of reflection also changes, so that the angle of incidence is always equal to the angle of reflection. Let's place the two laws of reflection of light on our concept board. When we talk about reflection of light, what's the first thing that comes to your mind? You must be thinking about a mirror, right? But do the other objects also reflect light? For example, if you look around in the room, to the table, chairs, walls, even you and me, are we reflectors of light? The answer's yes, because that's how we see the world around us. These objects do not have light of their own. They are reflecting the light coming from some luminous source, like the sun or a light bulb. As we discussed, all which objects reflect light. Now, an interesting question is, do all the objects reflect the light in the same way? What do you think? So, if you compare a mirror and a sheet of paper, do they reflect the light in the same manner? If that's true, then I don't need to buy a mirror, right? I can just comb my hair using a sheet of paper. But we know that's not the case. So let's go ahead and talk about the types of reflections. There are two types of reflections. One is regular reflection and second one is irregular reflection or scatter or diffuse reflection. A mirror or a highly polished surface is an example of regular reflection. But most of the objects around us like paper, walls, curtains are all examples of irregular reflectors of light because they scatter the light. It's easy to understand the difference between regular and irregular reflection. If we consider a parallel beam of light falling on a mirror and a surface like a paper. Let's look at the mirror case first. So as you can see in the plane mirror, the parallel beam remains parallel even after reflection. So if you look closely, you can see that all the rays in the beam have the same angle of incidence. Following the laws of reflection, all the rays will have the same angle of reflection. So the incident beam remains parallel even after reflection. Now let's look at the case of irregular reflection. When, when a parallel beam of light falls on a surface like a paper, as you can see, it gets scattered in different directions. Is this because of laws of reflection? Don't hold here. No, the laws of reflection always hold. The paper seems smooth, but if we look closely at a microscopic level, the paper is rough. So as you can see here, the angle of incidence for the different rays in the beam are different, and so the angles of reflection will also be different, and this is how the light gets scattered in different directions. So it's called scatter reflection, and another name for this case is diffused reflection. Let's put regular and irregular reflection on our concept board.